Great. Thanks a lot. Thanks for being here. I'm looking forward to the interaction that we're going to have. So let me just add a few things. Thank you, Lena, for that wonderful introduction. I am an environmental economist. I have been working on climate change policy and climate-related issues for the better part of 20 years. I didn't start out as an economist. I started out as an engineer. I briefly worked as a journalist. I've worked at major environmental nonprofits. But one of the things that I've always found very compelling about environmental problems as seen through the lens of economics, which you will see today in the talk, is thinking very carefully not just about why markets are great, but why the systems that we have and the institutions that we call markets might actually fail when it comes to the environment and issues of sustainability. And so really the starting point for a lot of environmental economists are the fact that we have a system out there that doesn't work, but yet at the same time something like incentives, prices, are really powerful. And so a lot of what we do is think carefully about policy design that gets the incentives right, such that we can, for example, reduce pollution, reduce greenhouse gas emissions, reduce our exposure to some of the worst environmental harms out there. A lot of my work within that framework focuses on thinking about not just how do we deal with climate change, what are policies to reduce greenhouse gas emissions, but recognizing the need to do that in a world that's already very unequal. So, for example, one thing that you wouldn't want is to be able to achieve, for example, like a 2-degree target around the world, but somehow in doing so exacerbate inequities that you already have in the world. So a lot of my work is thinking carefully about the situations in which you can both decarbonize, but then in ways that doesn't actually accentuate or exacerbate inequities that we already observe. And this is a case study of work that I think really highlights this tension, okay? So a lot of my work is focused on climate change policy design. I've done work in California, across at the US level, thinking about emissions trading schemes, taxes, incentives, and so forth. But then also a lot of my work is thinking carefully about how do we adapt to climate change, right? As temperatures rise, as precipitation patterns change, as water availability changes, what are the systems that we have that allow us to adapt? And how do these systems may actually help narrow inequities or maybe actually worsen inequities, okay? So this is work, joint work with a close colleague, Kelsey Jack, who's also an environmental economist at UCSB, a PhD student, Cassie Cole at Harvard, and then Martin Visser, also an economist at the University of Cape Town. The starting point here is really thinking about water, okay? About more than half of the world lives in cities, and most of water supplies in cities come through pipe systems, okay? They are a municipal water supply, okay? Your public utility provides you with water. And by one account, something like 1 billion people living in cities today are facing some form of water scarcity. And by one projection, that is possibly going to double through a combination of both demographic changes, more people moving into cities, and changes in water supply, in part driven by climate-induced droughts, okay? Here's a map from one recent account of this by the World Resources Institute, showing places currently that have relatively high levels of water stress. Not surprisingly, you see some of this highlighting some of the more kind of poorest places in the world, okay? But also, here in California, where we know we're facing kind of decadal-long droughts over the course of, throughout the Western US. A lot of what I'm going to talk about today will have some lessons, we think, to other experiences, and in particular in experiences we're having here in California. But we're really going to focus on one particular place in the world, all the way here in the Southern Cone, which is Cape Town, South Africa. Here is a picture of Cape Town. It is a beautiful city, in some sense not too different in terms of its geography as a Mediterranean climate, located on the water with mountains, in some sense not too different from being here in Santa Barbara, okay? This is Cape Town. This is also Cape Town. So in stark contrast to Santa Barbara, Cape Town is one of the most unequal cities in the world, in large part because of the history of apartheid and other kind of the remnants of colonialism in South Africa and in much of Africa in general. So 2 pictures. On the top is a kind of low-income neighborhood, slums if you want to call it, in the middle of Cape Town. And then on the bottom is a snapshot from a house from a wealthy neighborhood in Cape Town that could very well have looked like it came from Montecito. Okay? The picture on the right is showing you some index, one measure of inequality across global cities. And this is showing you that Cape Town, by this measure, is within the top 5 unequal cities in the world. You can come up with any kind of statistic to measure inequality. There are many. Cape Town will perennially come out on top. Okay? A very, very unequal city. Cape Town, like many places in the world, including Santa Barbara, gets most of its water from the public water supply, the city. And in particular, like much of the world, it gets it from large dams. Okay, so there are 6 large dams right here. This is the city of Cape Town. They basically supply municipal water, 98% of municipal water, to Cape Town's roughly over 4 million residents. Okay? The biggest one of these dams, right here, T. Waterskoof, looks like this when it's at 75%. This is considered normal. 70 to 80% is considered kind of typical capacity for this dam, the largest of the 6. Okay? That period of about 75% capacity was more or less what was going on for much of the last few decades. So here is a time series, monthly but smooth kind of data, showing precipitation, rainfall, over that dam that I just showed you, going all the way back to 1980. So one thing you will notice is that, yeah, if you kind of look at it, it does look like there's a kind of gradually declining trend, and this is something that climatologists have observed, that Cape Town and much of southern Africa is kind of in a general kind of drying kind of trend. But the thing that's quite remarkable is that I stopped this time series at 2010, in part to show you what happens after 2010. This is rainfall, average rainfall smoothed over a certain period after 2010. So even though there's a long time decline, the start of the 2010s really saw a very dramatic drying of the region. Accompanying this was this concern that reservoir capacities were starting to fall. Okay, so this is now total reservoir capacity. So on the that's what's showing on the y-axis. 1 just means full capacity. Okay. Now there's some kind of fluctuations due to seasonality, both in terms of rainfall. There's a wet and a dry season in Cape Town, and also kind of some seasonal kind of variation in use of water. And this dotted line on the bottom, marked at 13%, is the level in which literally, even though it's 13%, there's not enough water to supply the pipes because part of the reservoirs are silted, and you could not actually pump water into the city. And so what you see pretty dramatically is that starting in kind of the mid-2010s, there was this dramatic decline in reservoir capacity from about 70, 80% down to about 20 to 30%. Just to give you a flavor of what that looks like, remember this figure. This big reservoir at 75%. This is what it looks like at 20%. And this is what it looks like at 11%. Okay? This actually happened. So all of this period leading up to the beginning of 2017 became a moment of crisis for the city. In fact, so much so that people have basically commented that this is kind of the biggest example to date of a major city anywhere in the world just basically running out of water. All right? In fact, it was so dramatic that they had a very dramatic campaign and tagline associated with it. Many of you guys have heard of this. They called it Day Zero, which was literally the forecasted day, starting at some point in 2017, where the city would anticipate that the reservoir levels would fall below that dotted line, at which point the city would have to turn off its pipes for 4 million people. So how did the city respond to this? Well, the city did a lot of things that may not be unfamiliar for the Californians here in the room. Started off kind of doing like social campaigns, discouraging people from using water, right? Setting out pamphlets, setting out mailings, trying to use social pressure to discourage people from watering the lawns, for example. Okay? And accompanying that were a series of pretty stringent restrictions that got tighter and tighter over the course of 2017, as well as increases in municipal water prices. When prices go up, people consume less. Okay? So there was a whole basket of kind of policies, if you will, that the city was trying to do to basically keep water running. So just to give you a sense, so the first mention of day zero occurred in halfway of May 2017. The kind of a very important restriction that occurred in June of 2017 was restricting water use, daily water use, to 100 liters per day per person. How much is that? Just as a point of reference, the average American uses 3 times that amount. Okay? There were very large tariff increases, price increases. I'll show you what that graph looks like, those increases look like. And it kept on getting ratcheted down because there was basically this concern that day zero was approaching rapidly. In fact, so I'll show you, there was literally, in many parts of the city, a countdown clock for when the city will run out of water. Okay, so that 100 liters went down to 87 liters, which then went down to 50 liters. Again, think about the average American, 300 liters, okay, per day. 50 liters relative to 300 liters. And it was estimated in early 2018 that day zero, the day when the city would, despite all those measures, the day that the city would run out of water was on July 9th, 2018. Day zero was everywhere. Some of you might even have heard about it, might have even read accounts of it at the time. There were lots of kind of news coverage about how, all the conservation efforts the city had to undergo. All the billboards around the city had these signs that said you have to conserve. These were the restrictions. You have to use less than 50 liters a day. And then there was this countdown. There was this dashboard where anyone could go and just basically see literally the days counting down to when water will run out. Okay, so this was a pervasive experience if you're in Cape Town. And it was pervasive for everyone, whether you lived in, the kind of densely populated slums of the city or in the kind of leafy, guarded, gated communities with swimming pools. The prices went up dramatically. Prices is what's called volumetric pricing. You experience this if you buy water or electricity. Basically, the more you consume, the more you pay. To give you a sense of how much prices went up, the orange line here is during normal periods. The red line was what happened during the day zero period. So this was dramatic prices increases. And interestingly enough, they did not do the same for poorer households. And I'm going to return to this later because this turns out to have been very consequential in terms of equity. Okay, so what happened? So I showed you this graph before. This was the lowest point they hit. What happened? Well, it turns out day zero didn't happen. So after the initial announcement of day zero occurring halfway through 2018, they kept pushing it back. They kept pushing it back. And what eventually happened was that the reservoirs recovered, in combination in part because of some rain that had arrived that season. But the sum effect of this is by mid kind of 2018, the city basically said, wait a minute, we're going to stop this countdown. We think we're going to make it. We think we've dodged it. Okay? So in some sense, this was a success story. Here's an example of a city with 4 million, one of the most unequal in the world, managing to keep the pipes running. But there's another side. There's actually a lot more to this, and that's why I'm going to kind of walk you through. Because there's a question about how exactly did this happen, and what are the long-term consequences for the city due to this. Okay, so I'm going to tell you a little bit of a story. I'm an economist, which means I'm going to show it to you through a lot of data, a lot of figures. Okay? All right, so the first piece of data that we have is that we have the water billing data for every single household in Cape Town. So about several million households, okay? We have monthly water billing data and how much they paid for basically everyone in the city, okay? And we can see where they live, and we can figure out whether they are high income or low income based on the value of their property, okay? What does that look like? Cape Town is a very spatially segregated city. It is the quintessentially segregated city, if you will. Places, this is the city of Cape Town, places in light color are where the wealthy top decile households live, right? They're kind of like the Montecito gated community type places. And then the darker colors are where the lower income households live, okay? So I'm gonna plot for you time series graphs showing you monthly water consumption for the average household in each of the income deciles. Light colors are the richest, top 10%. Black colors, going darker colors, are the lowest 10%, okay? What do you see here? Rich are consuming, this is before day 0, rich are consuming much more than the poor. So to give you a sense, the rich here consume about 32 kiloliters per month, okay? It's like, well, what does that mean? The average Los Angeles household consumes 30 kiloliters per month, okay? The average Montecito household consumes 80 kiloliters per month. Okay, so just to give you a sense, this is very unequal, but it's still nothing compared to like, you know, your estates in Montecito or Beverly Hills. But you see a very clear income gradient. The rich are using more water. Okay, you can speculate for why that is, but we'll show you what it looks like it's happening. And it's seasonal, okay? When it rains, water is used less, which suggests, hints at something along the lines of outdoor irrigation, okay? All right, so 2 cycles. Now, this thing is declining because there's anticipation of water shortages. Everyone is using less water. But what I'm going to show you less is what happens to this dispersion during the day 0 period, when they started announcing that water was going to run out. So from January 2017 to mid-2018. It was an incredible fall in water consumption by everyone. But the thing that's more remarkable is look at the contraction. So it went from this incredible spread to almost, not only was it like no dispersion, but in some sense it almost even reversed. Like the richer households looks like they were even consuming less water than the poorest households, which seems like you cannot imagine that happening anywhere, okay? So this is remarkable, okay? The other thing that happened is now day 0 is over, they lifted the restrictions, prices went back to normal. What does it look like? It continued to be contracted. There's no dispersion. You would expect that this kind of fan shape would return after day 0 was lifted, that you would see the spread again with the rich using a lot more water, but you don't see that at all. Okay, so this is a puzzle. So now let's think about, kind of in a forensic sense, where could that water have gone to? So one argument is that, well, what we really want is some measure of total water use. One measure of total water use that may be missing from this account is that we're just interested, like, are outdoor irrigation really changing? Okay, so we use data from satellite remote sensing. There's, satellites that go across the planet that measure water content on the Earth's surface at a 20 by 20 meter resolution every few days. We take that satellite data, we kind of look it over town, Cape Town, and actually see what did water use, or kind of outdoor measures of water use, change during this period. Okay, so here's that measure, richest to poorest. You see a seasonal pattern, okay? This is kind of like the rainy season, right? Rich neighborhoods just have more moisture, right, than poor neighborhoods. But if you were to say that what you saw from before, what you would expect is that this dispersion would contract during day 0, and what we see is no contraction at all. In fact, this dispersion basically looks unchanged before, during, and after day 0. So there's no sense, at least from like our ability to observe this from satellites, that water content, outdoor water content, is changing for the richest neighborhoods than it is for the poor neighborhoods. Okay, so then you can see where I'm going. If their use of city water has fallen, the rich, but it's not because there are water in their lawns less, there's like an accounting problem. Like, where's that water coming from, okay? So what we're going to do is we're going to turn to city registrations for boreholes and wells. So the city requires that if you are going to drill groundwater, you have to register for the city. Okay? And in fact, the city encouraged this. They encouraged this very dramatically. The city, in fact, said, you should, if you are able to, try to access groundwater because it will save the city from running out of water. And that makes sense in the short run. It absolutely makes sense. They were running out of water. They needed to encourage people to do so. Now, the language here is very interesting. It says groundwater is effectively freely available to everyone in Cape Town. As I'm going to show you, it's definitely not freely available, but there are issues associated with thinking about it as is. But here's a picture of, like, in a wealthy neighborhood, basically like a suburban house with a large groundwater drill. And apparently this was all over a lot of neighborhoods in Cape Town. Okay, so here is the time series for a borehole and wells application. Boreholes are just basically deeper versions of wells. But you're thinking about it's like drilling for groundwater, okay, private drilling. The reason why you look at this, you're like, oh, the values are zero, is that they're not zero. It's just that the scale is so big that they look like they're zero. Why? Because here's what happens when day zero arrived. Dramatic increase in drilling applications for groundwater wells and boreholes. How does this differ by income? Well, we can split it like we did before, and you can see that basically it's driven primarily by richer households. Drilling much more than poorer households. Okay? All right, the final piece of evidence is, all right, so it looks like they're not using less outdoor water, so the water is coming from somewhere. Looks like it might be wealthier households turning to groundwater, okay? But we don't actually measure groundwater use, so we turn to a third piece of data, which is groundwater monitoring wells, where we can actually look at wells and compare kind of trends in groundwater levels between wells that are located near poor neighborhoods versus those located near rich neighborhoods. This is a time series, goes back further to 2003, of what groundwater levels look like for wells near poor neighborhoods. The shaded area again here is the day zero period. This is what it looks like for richer neighborhoods. So what you see here is kind of a similar trend that kind of parallel each other, and then this falls dramatically right around the time of day zero. This is some of the fastest falling groundwater anywhere in the world, comparable to some, the rates that we're seeing in parts of India and in China. Okay. So the story here looks like is that of richer households being able to quote-unquote dodge day zero by basically substituting away from public water to private water. They're paying for it, but as a result of which, they are using less public water and they're using groundwater. Or what are the long-term consequences of this? Well, there are two. One's environmental and one is about the kind of fiscal nature of public utilities. So let me just turn to what that means. So here, this is a tariff showing you showing you this before. This is the water schedule, the water pricing schedule that households face. The orange line was before day zero. The red line was during day zero, very high prices to induce conservation. And then the purple line was what happened after day zero. This is for kind of non-poor households. For poor households, this kind of at higher levels, the same thing happened. But interestingly enough, to the city's credit, they actually have this base first block up to 10 kiloliters per month that is free water. And in fact, the city extended that during day zero. They actually said, okay, despite all this that we're doing for conservation, we're actually going to allow for free water to the poorest households in the city. Okay? This mattered because you can plot the average price the households face over this period by different income brackets. And what you see is that there's a spread. The rich are paying much more than the poor. The rich and the middle class are paying much, much more during the day zero period because of those high prices. And in fact, that kind of dispersion has contracted in a way that wasn't in before day zero, and I'll talk about that a little bit more. But in fact, the poor households are actually now paying almost nothing for water. And this was very, very conscious on the part of the city of Cape Town to insulate the poor from the worst parts of the drought. And this was something that I think was very laudable in terms of the city trying to anticipate equity consequences of this. But there's still a kind of consequence for the middle class. What is that? In what sense? A public utility, like your electricity provider or a water provider, has to pay for the grid. If wealthier households are substituting or leaving the grid, that payment is now borne onto other households. And what we're seeing is there is a shift of the cost of maintaining the pipes from the rich onto the middle class in Cape Town. Okay? That's one consequence. That's an equity consequence. The other consequence is that overall, the city looks like it's losing revenue from municipal water. Why? Because now that wealthier households are basically bailing and say, well, I can just use groundwater because I've already drilled for the well, the city is now less able to recover the cost of maintaining its pipes, which itself benefits the poor, because the poor historically pay a lower share of those costs. And so now you have a problem in Cape Town, which is actually seen right now actually in the electricity sector in Cape Town, where they're actually having trouble maintaining or paying for the maintenance of the grid because all these wealthy households have basically bailed and said, we're off the grid, we're off the system. Okay? All right. So what is the story here? This is a complicated story. On the one hand, this is a success story. This was the biggest case, most dramatic case of a city running out of water, and they dodged it. Okay? So that's a success story, but it also has set up the city for some very acute long-term challenges. The rich are now basically relying more on groundwater, so they're not contributing to the public good of maintaining the public water supply. And there's questions about with groundwater. Groundwater is a classic open access problem. It's like drill, it's like a race to drill to the bottom. And that itself is a market failure. So the idea of like substituting from surface water to groundwater doesn't solve the problem. It just kind of pushes the problem onto another domain where now you're going to have groundwater extraction problems in the long run. What are the implications? Let me bring this back in my last kind of few seconds to think about what's happening here in California. This story in Cape Town is a much more dramatic case of what's happening in California, but it has analogs, okay? Let me talk about first about the cost shifting. So many of you guys have followed this debate, presumably about rooftop solar. So in California, there are very generous subsidies to households who adopt rooftop solar. In fact, they get subsidies to produce solar that can effectively sell back into the grid. But because of the pricing structure in California, wealthier households who are buying solar are actually not contributing as much of their share in terms of the maintenance of the grid, for which the costs are now much higher because of wildfire and so forth, okay? And so what's happening, there's a concern now, is there's just like an equity consequence, which is like, yes, the rich are like bailing out, they can be a little like their own like solar barons, but they're not contributing to the public good of providing electricity across the state. And that has some parallels with what's happening in terms of groundwater. And the last thing I will mention is that this concern about groundwater depletion is kind of endemic in much of the world, but certainly here in California. There is this concern that as kind of rainfall patterns shift, we're increasingly kind of relying on groundwater. Groundwater is historically unmanaged, so California has a law called the Sustainable Groundwater Management Act trying to manage groundwater, but that has faced its own challenges. So this is a case where you're kind of substituting one problem, accelerating another, and this other area is one where we have no management for, okay? All right, I'll stop there and I'll take some of your questions.